Start by writing down your I can statement, which is I can investigate relationships between quantities by using points on scatter plots. Pause the video if you need to write that down. Then what we're going to be looking at is data with two variables, which is called bivariate data. Bi meaning two, such as a bicycle has two wheels, so bivariate means we're going to have two variables in our data. A scatter plot will show the relationship between the set of data with the two variables, graphed as ordered pairs on a coordinate plane like we've been doing. That relationship is known as a correlation or an association. We can have different types of correlations, such as a positive correlation. We can have a negative correlation or no correlation. That is how the dots are moving. If all the dots are going in an upward trend, like with the blue arrow, then it'd be a positive correlation. If they're all going in a downwards trend, then it'd be negative correlation, like in the red. And if they're just all over the place with no types of correlation at all, then it'd be a no correlation. So in example 1, they want us to determine if it's a positive, negative, or no correlation. And is it a positive or negative? And then describe the meaning in the situation. So looking at those points, it looks like it's going to be a positive correlation. They are going in an upward trend. And in this situation, if we look at the labels on each side of the graph, we see that as the hours are increasing, the amount of wages will increase, which makes sense. The more you work at your job, the more you get paid. Now, for the U-Try, you're going to need to reference this video, and once you do, then you can check your answer with me in class. In example 2, you will make a scatter plot to determine whether the relationship exists in the data, if it's positive, negative, or if there's no correlation. And then we're going to draw a line that tries to pass through all the data points. Once we do that, we will use two of the points to make an equation for that line. And then we will use that equation to make predictions. So first I drew an X and Y axis, I labeled my points, and I went by 50s on the y-axis and ones on the x-axis. Then I began plotting my points. So I have 115, 2 125, 3 175, 4 225, 5 325, 6 435, and 7 483. So once I plotted all of those points, I labeled my graph as well, because it says that in the instructions to identify the variables. And I realized this is a positive trend. All the points are going upwards. So then I drew an arrow with a line as best as I could through as many points as possible with trying to keep it linear. So the main goal when you try to connect the dots is that you want to keep it linear. So although 2 points here are not in my line, that is okay, or 3 points if you look at 115, because you want it to hit as many as possible. It does not have to hit all of them. Then I picked 2 points that my line went through, which was 3 and 175 and 6 and 435. Then I found the slope of those 2 lines, and then picked one of the points to put into point slope form and wrote our equation. So our equation should be y equals 86.6 minus 86.6x minus 84.6. Then it asks us to make a prediction. So when I make a prediction, I looked at what it said. Predict the number of zebra mussels in 2039. My table says years since 2009. So x has to equal 30. and then I plug 30 in for x, and I should get, let's back that up, 2513.4. So I will pause on the screen for a second so you can get caught up. You can also pause the video so that you can finish writing it down. Next, you will skip the you try, because I'm going to show you how to do this all on a calculator after everyone watches this video. The last example we talked about previously, extrapolation, which means we predicted outside of the range of data. Now we're going to talk about interpolation, which means we're going to predict within the data set. So when we do that, we look at it says find the year 2010, and our graph is the year since 1980. So 2010 minus 1980 is 30 years. So I go to my table on the x-axis, I go to 30 years. I go up to the line. I want to know where does it hit the line, not the data point, but the line. And I look over to my y-axis, and it's at about 30 years, we will have about 2,400 people in attendance at the rodeos. Try the you try on your own, and we'll go over the answer in class.